everyone. Welcome back to the classes. How are you all? I hope you all are good. You all are doing very well. So, students, do you remember what we have studied in the last session? Exactly. We have started our new chapter that is the metals and non-metals. And in the last session, we have discussed about that what are the metals, what are the non-metals, that metals are electropositive in nature and non-metals are electronegative in nature. And what else we have discussed? Do you remember? Have you watched the last session? So yes, we have studied about the physical properties of the metals and the physical properties of the non-metals as well. Then we have discussed about some exceptions, that what are the exceptions in the metals and the non-metals. Fine. So, students, today what we are going to do is that today we are starting the new topic of the same chapter. Now we are going to see that how the metals and non-metals react chemically. That we have seen that okay, physically they are having such properties that metals are sonorous, metals are lustrous, metals are this, metals are those. So we have discussed all such things. Fine. But now we are going to see that how the metals and non-metals react chemically. So if we see here, these are the topics covered which we have to cover in this session. That the chemical properties of the metals we have to see. Then these are the chemical properties which we are going to discuss in today's class. That how the metals react with the air and what they are giving in the product, and then the reaction of the metal with the water, like how they are reacting with the water and what they are giving in the reaction. Fine. So we are going to discuss all of these topics or all of these reaction of metals in today's session. Fine. So students, now starting with the topic that what is the chemical properties or how we can say that how metal is reacting if in the presence of oxygen or in the presence of the water. So we'll see those reaction one by one. But as we can see here that something is written है ना? So what we have to see, alkali metals like lithium, sodium, potassium react vigorously with water and oxygen or air. Okay, so they are telling you that these metals on reacting with the water and oxygen, they give some kind of vigorous reaction. That means you can see very very fast reaction will be there and very vigorous or dangerous in nature it would be. Okay, and you will come to know that why they are doing so. Fine. Then if we talk about the water, that how they are reacting with the water, so magnesium reacts because this is magnesium, Mg is magnesium. Magnesium reacts with hot water. Aluminium, this is aluminium. Fe is what? Fe is iron. Zn is zinc. So they react with steam, and this is Cu is copper. Fine. Ag is silver. Pt is platinum, actually not platinum. Au is gold. Fine. So now do not react with water or dilute acid. Now you can say, ma'am, why you are telling us these points? Please tell some chemical reaction. See, students, some metals, like it depends upon the chemical reactivity of the metal, that how much the metal is reactive, that whether it is very reactive in nature or whether it is less reactive in nature. So all such thing depends upon their chemical reactivity. Fine, that how much reactive they are. Like lithium, sodium, and potassium, they are reacting very vigorously in the oxygen air, and even the magnesium is reacting with the hot water. So it all depends on their chemical reactivity, that why they are reacting with hot water, why some metals are reacting with the steam. So all such things students tells about their chemical reactivity, that how much the metal is reactive in nature. If any metal is just reacting in a very I can say in a very minor condition, that you are not giving any special condition to them, and even though they are also showing some reaction, they are giving some product, so you can say that they are very reactive in nature. But to make some reaction, or but to carry out some reaction, if we have to do something, like we have to give some special condition to that reaction, in that case students, we can say that that metal is not that much reactive. That is why we have to change the condition. Exactly. So, on the basis of that, student, we are going to see such chemical properties of metals today. So, first of all, the reaction of the metal with the air, that how the metal is reacting with the air and what we are getting from here. Fine. So, if we talk about that, what's the reaction is going on, or what we are reacting with, what we are getting in the reaction when the metal reacts with air. So, it's a very like simple thing. You don't have to be worry about that what you are getting from here. So it's like when metal, okay, so the metal when reacts with oxygen, we know that either you are giving it to oxygen or you are getting oxygen from the air, because air contains the oxygen. So by reacting the metal with the oxygen, it formed the metal oxide. That means metal oxide, and which is also basic in nature. That means, students, metals on reaction with the oxygen, they form the basic oxide. Basic oxide means, students, that if you remember from your acid, bases and salt chapter, that if you put a red litmus paper into it, so that red litmus paper will convert into the blue litmus paper, because that oxide which has been formed from this reaction is basic in nature. Fine. Now, how they are reacting? So just look at here. See, they are telling this thing like sodium and potassium are kept immersed in the kerosene oil as they react vigorously with air and catch fire. Because, student, what happened, like sodium and potassium, these two belongs to the alkali group, and the alkali group is very reactive in nature. They are very reactive in nature. How they are very reactive, students? Because they are highly electropositive. Highly electropositive. Now, why they are highly electropositive, students? Because what happened, that sodium is having the atomic number of 11. That means if I do the configuration, so it would be 281. So to attain its stable configuration, or to match the level of noble gases, what they have to do is they just have to donate this one electron. And the donation of one electron is not a very difficult task, it's a very easy task. And if it is donating its electron very easily, so that's how, student, they become very reactive in nature. That is why, students, sodium and potassium, they both are the alkali group, belong to the alkali group, and they are very reactive in nature. That means both of them just have to donate their one electron, so that they can acquire the stable configuration as similar to the noble gases. That is why, students, sodium and potassium are not like, we have to store them in the kerosene oil. If you are just keeping sodium or potassium in the open atmosphere or directly in the contact with the oxygen, so there will be a very vigorous reaction, and which could be a dangerous thing for you as well. That is why, student, we don't keep sodium and potassium in open surrounding, we have to keep them immersed in the kerosene oil, because they are highly reactive in nature, because they are highly electropositive. That means they just have to donate one electron, and due to that, student, what happened, they become very reactive in nature. So that is why, if you see that when K, that is the potassium, reacting with the oxygen, form the potassium oxide. And this potassium oxide, yes, definitely it will be basic in nature, but the reaction will be very vigorous. Fine, students. That is why we have to see that how the metal is reacting, and whether the reaction is not vigorous or vigorous. So that's how we have to see, depending upon the chemical reactivity of the metal. Fine. So that's how the sodium is also the same condition, that when sodium reacts with the oxygen, so it gives a highly vigorous reaction, because sodium and potassium, both of them are highly reactive. Fine, students, I hope you got this point. Okay, so now you'll say, ma'am, just give us some another example, so that we come to know that what's the exact reaction with the metals. So, students, what happened, as I told you, depending upon the chemical reactivity of the metals, we see that whether they are reacting with the oxygen very easily or not. So, see, students, sodium and potassium, they are reacting with the oxygen like they don't require like any other condition or special condition. They are just reacting with them, with the oxygen. That's why they are highly reactive. But if I talk about copper, because with what happened with the copper, when copper reacts with the oxygen, so what happens, student? So there is a formation of the copper oxide. That is the 2 copper oxide. But this reaction is not vigorous. Not vigorous. Now, why it is not vigorous, students? Because copper is not that much reactive, because copper can't lose its electron easily, or you can say that it is less reactive than sodium and potassium. That is why it is not reacting with the oxygen very easily. It requires some special condition. You have to provide more and more heat, so that it can react with the oxygen. But definitely you will be getting metal oxide, and it will be basic in nature only. Fine. So it generally depends upon the type of the metal which is present there. Either you are having a very reactive metal, or you are having a very less reactive metal. Fine, students. So that's how, if a metal is very reactive, so it is reacting with the oxygen, forming metal oxide, and it will be a vigorous reaction, as in the case of sodium and potassium. But like copper is not that much reactive. So when it will react with oxygen, so definitely it will not give any type of vigorous reaction. Fine. Okay. Now, students, you have to keep one important point here, that we are having basic oxide, we are having acidic oxide. Like students, metal react with oxygen, give basic oxide. So, similarly, when non-metals react with oxygen, so they give non-metal oxides and they're acidic in nature. Fine. But along with these two, we are having one more type of oxides. Now, what they are? They are called as the amphoteric oxide. Amphoteric oxide. That means neither they are, like you can say, maybe they are acidic in nature or maybe basic, or you can say they are both in nature. So that's how you can say, when a metal react with oxygen, and if it is forming a metal oxide, so that metal oxide can also react as a basic oxide or can also react as a or acidic oxide. It can play both the role. So such type of oxides are called as the amphoteric oxide. Fine. So the example of amphoteric oxide, if you want to see, so it would be aluminium oxide. Aluminium oxide, that is the Al2O3, and the another one is the zinc oxide. Okay, and that is the ZnO. So these two are the amphoteric oxide. That means, student, these two can be the acidic one as well as the basic one. If the aluminium oxide is reacting with the base, so it will behave as an acid, and if the aluminium oxide is reacting with the acid, so it will behave as a base. So that's how they can play the role of both depending upon the condition, that whether they are getting the acid or a base in the reaction, and they can perform their reaction. So that's why these are the amphoteric oxide, students, which can behave either both, like basic oxide as well as the acidic oxide. Fine. So these two are the examples of the amphoteric oxide. One is the aluminium oxide and second is the zinc oxide. Okay. So that's how we have seen that how the metals are reacting with the air and they form the basic oxide. But as we are having one more type, that is the amphoteric oxide, in which they can react like both, because aluminium and zinc both are the metal. So that means we are getting metal oxide, but they are reacting as the both basic as well as acidic. Okay. Now moving towards the different type of reaction, that how the metals react with the water. Okay. So students, what happened that when metal react with water, so we are having three conditions. First, second, third. So it's like cold water is there. That means you can see, not, I'm not talking about ice water, cold water, like a normal water, we can say. Then we are having hot water. That means we are heating that water. Then we are having steam. Okay. So these are the three different things here. So what happens, student, if there is a normal water and you are putting, so what, okay, I'll tell you now. You are having three beakers, and in one there is cold water, in one it is hot, and in the another one like steam are forming. Okay. So what happens, student, that if you're adding any metal, let's say, I can take the example of sodium. And sodium, when you add it into water, so it is giving you direct reaction, like you don't have to heat water or you don't have to form the steam. That means it is easily reacting with the water. So that's a, student, when metal reacts with water easily, that means you don't have to heat the water, you don't have to form these steams. So and that particular condition, we say that the metal is reactive in nature, very reactive. But students, as we are having some different examples as well, the metals which are not that much reactive, so for that we have to give the special condition, like we have to provide them hot water, we have to provide them steam. But some of the metals are also there which are not even reacting with the steam. That means they are very very less reactive. And see, student, that we are have for this we are having one chemical reactivity series of metals as well. So don't worry, we will see that also. Okay. So first of all, how the metal is reacting with the water. So when metal like M reacts with water, so it forms metal hydroxide, that is MOH, and along with the hydrogen gas. Some of them produce metal oxide. I'll give you the example. Okay. So, students, as you can see here, that hydrogen gases evolved. So, first of all, they are giving you the example of sodium. And we know this thing from the last reaction, that the sodium is very reactive in nature. That means it would not require any special conditions. So, if even though you are giving it cold water, then also it is forming the sodium hydroxide. There is the hydrogen as well as heat is evolved. That means there is the formation of metal hydroxide and it is base in nature. Hydrogen is getting evolved and the heat is getting formed. Oh, I'm so sorry. Then if you look at calcium, calcium is also reacting with the cold water and forming calcium hydroxide and hydrogen. Magnesium reacting with the hot water. That means, student, if magnesium is not reacting with the cold water, so sodium and calcium, so you can say that these two are more reactive than the magnesium, because magnesium requires the hot water so that it can form the magnesium hydroxide as well as the hydrogen. Exactly, students. But if you give, like, magnesium is there and H2O is there and steam is there, okay, because you know na, that the hot water and the steam both are the different things. So when it is reacting with the steam, so it will form the magnesium oxide. And when it form the magnesium oxide, then there would be the hydrogen gases also getting evolved. Okay, so that's the case, students, that some of the metals react with cold water, some of them react with hot water, and some with steam. And even though there are some metals which do not react with steam, that means they are very, very less reactive. That is why they are not reacting in any of the condition. Fine, students. So this is the condition. But now, if I say that you can detect the presence of the hydrogen gas, so how can you do that? Okay, so for example, this is a beaker, okay, and it is having water, cold water, let's say, and this is the water, and in that you are adding calcium. Okay, if you're adding calcium here, so what is getting formed here? That first of all, calcium hydroxide is getting formed and the hydrogen gas will evolve. That means hydrogen gases get evolved. Now how you will detect that whether it is the hydrogen gas or not? So students, what you can do is you can put the candle near to it. You can put the candle near to it, and when these bubbles of the hydrogen or the vapors of the hydrogen gas, when it getting burned in the presence of the candle, so what will happen? There is some pop-up sound, like the pop-up sound will come. And when there is a pop-up sound, students, so definitely it will be the hydrogen gas. Fine, so that's how you can detect the presence of the hydrogen gas when a metal is reacting with the water. And it's not like that every metal can react with hot water or steam. It depends upon their chemical reactivity. That sodium, it's very reactive in nature. If it is reacting with cold water, so the reaction will be very fast. But if we talk about magnesium, so the metal is not reactive that much, if we say. So that's how it will require hot water. Fine, students. And even though, like, in the very starting they have written some points, so that's how they have written, because depending upon the chemical reactivity of the metals, like magnesium reacts with hot water, aluminium, iron and zinc, that they are reacting with the steam. That means aluminium, magnesium is more reactive than aluminium. Okay, and the copper, silver, these are very, very less reactive, that they do not react with water. So that's how, student, depending upon their reactivity, that which type of metal giving the reaction very easily and very fast, so we consider them as the very reactive metal. But if we talk about the metal for them which we have to change the condition, in that case you can say that the metal is not that much reactive. Fine. So, like, as I told you, sodium and potassium, why they are reactive? Because they're highly electropositive. They just have to lose their one electron. That's why they react very easily and give vigorous nature. So that's how, from the reaction of the metal with air, they are getting basic oxide. That means if you do the litmus test, so the red litmus converts to blue. And the same thing with the reaction of metal with the water, that there is the metal hydroxide. If you again do the litmus test, so that means what you are getting, if it is a base, so you will getting that red converts to blue and hydrogen gas. And even though I have told you that how you can take the presence of hydrogen, that when candle is near to it, so there is some pop-up sound. Okay, so that's how, students, you can do these two reaction, and they are very easy again. Fine. Now, after discussing these two reactions, now one question is here. Saloni took a piece of burning charcoal and collected the gas evolved in a test tube. How will she find out the nature of the gas? See, burning of charcoal. So, charcoal is here and charcoal is getting burned. Now, students, if I tell you that charcoal is the part of the coil only, and the coil is having the carbon content, and when carbon is burning in the presence of oxygen, so definitely, student, there is the combustion reaction. Okay, and what happened that when there is a combustion reaction, so definitely there is the evolution of carbon dioxide. Okay, this is the carbon dioxide. Now, students, if you remember that when I was telling you about the basic oxide, so I told you we are having one basic oxide in like when metal react with air, so we get basic oxide. But when non-metal reacts with air or like oxygen, so we get acidic oxides. So, students, carbon is what? Carbon is non-metal. Non-metal reacts with oxygen, so it forms carbon dioxide. That means it would be acidic in nature. Acidic oxide. This is the acidic oxide. So now what we have to tell that how will she find the nature of the gas? Okay, now it is the acidic oxide. Now what you can do, student, that in a test tube which is having the gas, you can add some drop of water, then cover it and shake it. So what will happen that the gas will dissolve into the water. And when you do this thing and you will test with the blue litmus, so what will happen that blue litmus is converting into red. So what that means the gas is acidic in nature, and that's how we are getting carbon dioxide. And carbon dioxide is what? It is a non-metal oxide. Non-metal oxide which is acidic in nature. So definitely student, if you are putting blue litmus, so it will convert it into red. That's how student she will come to know the nature of the gas, that whether it is the acidic in nature or basic in nature. Fine. So I hope you got the point that how you can detect the presence and how the metals is reacting with the water or how the metal is reacting with the oxygen. So on the depending upon the reactivity, some of the metals react with oxygen and water very easily, but some of them require some special condition. Fine, but they both are producing some basic nature, like whether it is basic oxide or whether it is basic hydroxide. So both are forming base part only. Okay, so that's our student. We have completed the today's session. Now in the next session, we are going to look at new reactions. Fine. Now what you have to do is you have to study well and you have to do more practice about the reactions. And it's just that if you're having any doubt, any question is there related to these two reactions, you can put your question on private or public forum of Ask IITians and you will getting your answer from the expert side. Okay, till then watch the videos, learn well and clear your concepts. And in the very last, thank you so much for attending session and keep learning from Ask IITians. Thank you.